This last section in our graphing chapter is on what is called slope, and I'm actually going to divide this section into two different videos so that they're not quite so long. So if you look at the top of your notes, you will see a definition of slope. But first off, I just want to give you sort of a layman's term definition for slope. Slope just has to do with the steepness. I'm not even sure if that's really a word. The steepness of a line. How steep is that line that we're talking about? So in order to find out how steep it is, we talk about the change in the y, or the vertical change, over the change in the x. The quick way to say that is the rise over the run. It's like a stair. Let me draw this at the top. A staircase can be very steep, like this, where that change in the rise over the run is very steep and my line is steep, or a staircase might be like this. This is an exaggeration, where it's not very steep, where the rise over the run is a much smaller number. So let me just show you what I'm talking about. Here on your page, you see I already have a graph, and the graph goes through some points. We talk about this point. This is the point 1, 2. Then I have this second point, which is the point 4, 6, and the third point, which I believe is the point 7, 10. Now what I want to do is I want to show you, I'm going to do it in several different cases. I want to find the steepness of the line between these 2 points. So between the point 1, 2 and 4, 6, and I'm going to do that here in blue. And by my definition, it says the rise over the run. So how much does it go up compared to how much it goes over to get back to my line? So if I start here and I count the rise, it rises up 1, 2, 3, 4. So it goes up 4, and then to get back to my line, I go 1, 2, 3 to the right. So right 3. Well, we learned when we were plotting points that the up direction is positive, so that's a positive 4. The right direction is positive, and I get my slope at that point between those 2 points of my line is 4/3. Now, just to kind of make a point here, let's look at the steepness of my line between those 2 points, and I'll do this in green. Between the points 4, 6 and 7, 10. Well, now think about that for a second. Is the steepness of the line there different? Did that steepness change? It really didn't. It's the same line, isn't it? So let's look at it. Here, if I do rise over run, it's going to be up 1, 2, 3, 4. So once again, it was up 4. And then here, it's right 1, 2, 3. So it's exactly the same, and I still end up with 4/3. All right, in red, let's look at the steepness of the line between the points 1, 2, and all the way up here to 7, 10. So we want to look at the whole steepness. So we're going to do rise over run. So I go up 1, 2, 3, 4, 5, 6, 7, 8. Now I'm up where I need to be. So I went up 8. Uh-oh, that looks different, doesn't it? And then I'm going to go right 1, 2, 3, 4, 5, 6. I went right 6. So here my slope is 8, 6, and it appears to be different until you simplify this. And it simplifies to 4/3, which is the same as the other 2. The point being, it doesn't matter between which points you check for slope. On a straight line, it's always going to be the same. And in fact, let me see if I can do it with another color that will show up. Let's try it with this purple color. Let's try it between 7, 10 and 1, 2. So we're going to go down counting. So how do I get from this point traveling down to this point? Well, I have to go down first, don't I? So we go down 1, 2, 3, 4, 5, 6, 7, 8. So I go down 8, and then I have to go left 1, 2, 3, 4, 5, 6. I went left 6. Well, down is a negative direction, left is a negative direction, and when I simplify that, I still end up with 4/3. So the point is, it doesn't matter which points you travel between. The slope of a line is what it is. It's consistent. And notice, when we're talking about slope, it's always the vertical direction over the horizontal. And it's not a point. I'm not doing this. It is a relationship between the rise over the run. That's different than when you plot a point, and plotting a point is actually left or right first and then up or down. And I know that's confusing, you just have to learn it. So there is a formal math definition of slope. We know that rise over run is part of it, but we also know that rise is how does the y change. So that is y2 minus y1. Those little subscripts just mean first and second. So second y minus first y, divided by change in x, which is x2 minus x1. So let's try one, and you'll understand what I mean by y2, y1 in just a second, and x2, x1. It says find the slope of the line between, or that goes through -1, 5, and 2, -3. Now I could plot those points and count them, and in fact we're going to do that in a minute. But I want to show you first how to do it with this mathematical definition. And by the way, you have to memorize that formula. I'll show you an easy way to remember it in just a minute. So this is my first x, my first y, my second x, and my second y. So it's x1, y1, x2, y2. That's how you label the points. And then you just fill in the definition. M stands for slope. I have no clue why. I Googled it even and I can't figure out why. And now we're just going to plug in. y2 minus y1 would be -3 take away y1 over x2 take away x1. Be careful. It's not just 2 minus 1. It's 2 take away -1. Well, this is a -8. That makes a positive over 3, and my slope is -8/3. Now let's see if we get the same thing if we plot those points and we count the slope, rise over run. So if I plot the first point, it's -1, 5. The second point is the point 2, 1, 2, 3, -3, which is right there. I am going to graph my line by connecting my two plotted points. I didn't quite get through that one. It's hard to do that. All right. So now let's travel from here to here first, and I'll do that in green. So we would be going down 1, 2, 3, 4, 5, 6, 7, 8. That gets me to the right spot. So I went down 8. Now to get over to this point, I have to go right 1, 2, 3. Right 3. Well, down 8 is a negative, right 3 is a positive, and sure enough, I got the same. All right, in purple, let's travel from this point to this point. So I would have to go up 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8, and now I have to go left 1, 2, 3. Left 3. Well, up 8 is a positive, left 3 is a negative, but a positive divided by a negative is still a -8/3. So I get the same thing no matter which way I do it. So you need to memorize this formula right here, and you need to be able to also count between points by doing rise over run. Now let me show you a quick way to memorize this, and it's kind of silly, but if it helps you remember, then good. All right, so let's say you were going on a picnic and you're going to take wine. So I call this the wine picnic. So you would have a picnic table. The legs of the table would be underneath. That's your X's. On top of the table, you have your wine glasses. Those are the Y's. Just remember there's negatives in between, and you have it. Excuse me. Let's look at the next page, and we're going to find slope again by using our formula. And this time we will graph it, but we're not going to count it out. So find the slope of the line that goes through the points -1, -2, and 2, 4. So the first thing you want to do is label x1, y1, x2, y2. Always do that. Slope is equal to y2 take away y1, watch your signs, over x2 take away x1. Well, that makes a positive, that makes a positive, and I have 6 over 3, which is the same thing as 2 over 1. It simplifies. And yes, you do want to simplify. You could say slope is just 2. All right, so let's plot it and look. So we've got -1, -2, and then we have the point 2, 1, 2, 3, 4. If I connect those two to graph my point, and I counted it, I'm not going to take time to do that now, you would indeed see that my slope is 6 over 3. Well, then where does the 2 over 1 come in? Watch. Up 2 over 1. It gets me back. Up 2 over 1, up 2 over 1. So if I do that 3 times, I end up with the 6 over 3. Now I want you to notice something. On this one, traveling left to right, my line is going up, just like it is right here. The line goes up. So when the line goes up, my slope was positive. I had positive slope. If you look at the page that came before, right here, my line is going down as I travel left to right, and my slope was negative. So we can make a conclusion that when our line goes down, and again, I'm talking about from left to right, the line goes down, okay? The slope is negative, and that will always be true. Negative slope is on lines that are traveling downward, and positive slope is on lines that are traveling up as you go left to right. All right. Let's look at example 3, and you're going to see a kind of a neat coincidence here. It says find the slope of the line y equals 3x minus 2 by finding 2 points that satisfy the equation and then using the slope formula. So first I have to find 2 points that are on my line. Since the y has a 1 in front of it, it is easier to pick for x, so of course I'm going to pick easy numbers, 0 and 1. If I pick a 0, I have y equals 3 times 0 minus 2, or just y equals -2. There's 1 point. Now I'm going to pick a 1, so that would be y equals 3 times x is 1 minus 2, y equals 3 minus 2, or y equals 1. So now I have 2 points. I have the point 0, -2, and I have the point 1, 1. I will call this one x1, y1, and this one x2, y2. And by the way, it doesn't matter which one you call which. It's always going to come out the same. So to find the slope between those 2 points, I'm going to use these 2 points now. It's going to be y2 minus y1 over x2, which is 1, minus x1, or 3 over 1, which is 3. Now that was kind of a lot of work. So let's go back and let's look at our equation again. Y equals 3x minus 2. Here is my slope. Do you notice anything coincidental about my slope and my equation? What do you notice? This is a 3. This is a 3, the coefficient of x. Is that a coincidence? No, it's not. So when I have my equation in this form, I really didn't need to go through all of this rigmarole. I could have just looked at it, and I know that the number in front of the x is going to be my slope every single time. provided my equation is solved for y. Now let me show you another coincidence that you may or may not have caught. Look at this number. Do you see it anywhere else in the work that we did? Look there. There it is again, -2. And what is that point? That point is my y-intercept. Is that a coincidence? No, it is not. So let's look at the next page, and we're going to make a conclusion that is one of the handiest things in mathematics to know. And that is this. When a linear equation is solved for y, meaning it's y equals, okay, then the coefficient of x is the slope, and the other number is always going to be the y-intercept. So it says, in other words, the slope of the line given by this equation, this is one of the most used equations in math. We call it y equals mx plus b. This will always be the slope right there. And this, the b, and we always call it b, is the y-intercept number. So let's look at a couple. If you have the equation y equals -3x plus 4, oops, let me scoot this over, then our slope is -3 right there. Don't even have to do an xy table and find 2 points. I can read it right off. And the y-intercept is, now don't say 4, it is the point 0, 4. You always have to give the intercept as a point. Here, y equals 2/3 x minus 7. The slope is 2/3. And the y-intercept is the point 0, -7. Here, the slope is the number in front of the x, the coefficient, is -5/3. And the y-intercept, do you see a number there? No, it must be 0. The y-intercept is the point 0, 0. Very, very handy. So let's try a couple more. Find the slope of the line, -2x plus 3y equals 11, without using an xy table. Well, what you have to know is that the equation must be in the form y equals mx plus b. It can't be like this. Well, how can I make this equation look like this equation? I solve it for y. And I do that by adding a 2x to both sides. Now I have 3y equals, let's write the x first, 2x plus 11. I divide everything by 3, and I end up with y equals 2/3 x plus 11/3. Now this equation is in that form, so now I can tell you that my slope is right there. It's the coefficient of x. Don't write m equals 2/3 x, it's just m equals 2/3. So you're forced to have to get the equation in that form first. Let's do the same thing here. It almost is in that form, except this says -y. No, it can't be -y, it's got to be positive y. So we're going to divide everything by -1 to get positive y equals -5x, negative divided by negative, plus 2. And so now I know that my slope is -5. My slope is -5. All right, let's fill this last piece in, and then I'm going to stop this video, and we're going to continue this with, well, we'll do a couple more, and then I'll stop. An equation of the form y equals n represents a horizontal line. We talked about this before. And an equation of the form x equals some number represents a vertical line. So let's look at the slope of some horizontal and vertical lines, and then we'll stop and do the second video on this section. So it says find the slope of the line y equals -1. Well, I'm going to show you the long way first, and then I'll show you a shortcut. So I need, to do slope, I need 2 points, and this tells me y has to be -1. So it's very simple. I pick whatever I want for x, and I now have 2 points, 0, -1, and 2, -1. I label them x1, y1, x2, y2, and I fill in my slope formula. So it's y2 minus y1 over x2 minus x1. This is a 0, this is a 2, and I know that 0 divided by any number is just 0. The line, if I graphed it, is a horizontal line that goes through the point y equals -1. So this is a horizontal line, and its slope is 0. And that will be true for all horizontal lines. They will have a slope of 0. You can remember that. The word horizontal has zeros in it, and it also has a Z for 0. Horizontal lines have 0 slope. So if you memorize and you know that y equals some number represents a horizontal line, you don't have to do all of this. You can say, oh, well, I know that slope will be 0 then. So let's look at a vertical line and see what its slope is. And again, I will do it the long way first. So let's find 2 points. X has to be 5. Y can be whatever you want because it's not there anyway. So I've got 2 points, 5, 0 and 5, 2. X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. What is anything divided by 0? It is undefined. It's not 0, it's undefined. And if I graph the line, y equals 5, it is a vertical line, which I hope you remembered, or excuse me, x equals 5. I hope you remembered that from the fact that it's x equals some number. Those are always vertical lines. So this is vertical. The slope of all vertical lines is m is undefined. Horizontal, 0, vertical, undefined. And so here is a summary at the bottom. Lines moving upward, positive slope, so the slope is greater than 0 because it's positive. Lines going downward, negative slope. Horizontal lines, m equals 0. Vertical lines, m is undefined. So we will stop here and finish the rest of this section in a second video.